measurements. It takes, again, hours and requires much larger samples because of sensitivity. So again, we combine all those together to get something about membrane. So with that, by way of sort of a long introduction, I'm going to give a couple of examples now of where we were using this kind of analysis on different highlights of different membrane systems we're looking at. So the first few examples I wanted to give were from Hirsch Nanda, who's another scientist at the NCNR, who works with us also at IVDR. And so basically, this slide highlights that in addition to what we have showed you already for using nucleotimetry to look at the bilayers, if we have surface-associated proteins with those bilayers, you can get a sense of where the protein is relative to the membrane and get an idea of the projection of that protein structure on the bilayer from the scattering, again, using reflectometry, and then you can fit those, again, to scattering length densities. And so here's just one example where we can, again, using different, basically, contrast matching and then simulations, you can get a sense of where the bilayer membrane is here, and then there's extra scatter out here, which is attributed and assigned to the protein. So you can get a sense of how much the protein scatter extends out from the surface, its distance from the surface in this kind of a measurement. So what kind of questions can you address with this kind of information? So the first example of this I will show you is the HIV GAG protein. So HIV GAG is a multi-domain protein that's involved in HIV assembly. So basically, at one point in the viral life cycle, the GAG protein is made. It contains a number of modules which are cleaved by the HIV protease, and those modules